All right. Good morning, everyone. Welcome to the University of Wisconsin-Milwaukee's Connected Systems Institute Thoughtful Thursday lecture series. I'm Charles Mosley, and I'll be your host for today's lecture, The Business Value of IoT in Manufacturing, presented here today by our very new Executive Director, Mary Bunzel. Mary comes to us with more than 30 years of experience, most recently at Intel and IBM, where she managed global teams responsible for advancing the adoption of the industrial Internet of Things technologies in the world's largest manufacturing enterprises. These experiences help shape the vision she's created for the Institute and how we'll accomplish our goals to create the workforce of the future for manufacturing. In today's session, she'll explain the compelling reasons driving manufacturing enterprises to accelerate their adoption of industrial IoT and how best practices in asset management and operations affect the outcome of implementations. Before we begin, some housekeeping. Please keep your microphones muted if they have not already been auto-muted by Microsoft Teams or the web. Please join us in our chat function. It should be near the top of your screen and looks like a chat window. Enter questions in there and we'll answer them at the end. If you're having any technical difficulties, please reach out to me at cmosley@uwm.edu. Okay, Mary, take it away.
All right, thank you very much, Charles. Do we have slides on the screen, or? Here we go.
Are your slides popping up?
Here we go.
There we go. Okay.
All right. Thank you, everybody, for joining me today. I'm really excited to talk to you about what we're doing here at the Connected Systems Institute relative to advancing the cause of enabling technologies we collectively know as the industrial Internet of Things for factory automation. And, you know, when we talk about the factory of the future, there's a great deal of promise and expectations that come from what we know the technology is capable of. You know, things like machines that can talk to each other and who can perform completely autonomously because the conditions that they need to operate in and the mission that they're intended to achieve is programmed and expressed through that equipment. So social machines work together perfectly with perfect insight. Sometimes those machines might augment operator efforts. So, for example, cobots or other devices that are assistive in nature to human capabilities. So the factory of the future can also contain augmented operators and assisted operations. In addition, we know that the industrial Internet of Things can disrupt markets completely by making products differentiated through the use of smart technology that makes them visible and intelligent and able to connect and communicate their condition and status in the manufacturing process autonomously, thereby making their inventors more aware of how that product is performing out in the field. We'll review this a little bit more later in the session and how impactful that is for markets, along with the opportunity that IIoT is bringing to us in manufacturing. In addition, the idea of having virtual production, in other words, systems that are completely dedicated to linking the consumer with the provider and operating together seamlessly with most perfect inventory levels and buffer and unique offerings so that indeed you could meet the goal of delighting customers through lot size of one. All these are promises of and expectations that we have for the factory of the future. The question is, you know, how are we going to get there? And we know that the improvements driven by industrial Internet of Things can be really significant in almost every pillar of a business operation. You know, if you start with asset utilization and the idea of being able to run an asset in its perfect condition without overdue stress or sweating the assets, as we say, to wear them out prematurely, This relates to the inventory and labor resources that are kept on hand. Many times organizations try to over-insure against lack of availability of these sorts of assets by overstocking inventory, overstocking the labor resources. So there are significant savings in those regions when you optimize how the production flows and maintenance flows in an organization are operating. Quality issues always erode, they erode the available production time because it's consumed a cycle which is producing something that can't be sold. It also creates risk in your consumer and the customer experience that comes from working with your products if quality isn't at where it should be. Now, all of this is related to supply and demand, alignment, and overall time to market. So there are significant savings that can be reached in every area, but really, I mean, the question is, how do we get there? Some postulate that our GDP growth, in fact, depends on this acceleration in productivity. You know, in the last 50 years, we had enough population where we could produce the GDP goals and growth that we would want to as a company, as a country. The next 50 years, with lack of population growth, and if there's no additional automation that comes, we'll actually experience a loss in GDP, which is not something that we want, especially now coming out of this pandemic. So really, technology and the ability to automate operations in this challenging world of labor availability, skill availability, and capital availability becomes utmost importance for every person who's steering an organization. So we have to figure out how to get there together. If we drill down into where we think industrial IoT is going to have the most impact, we can sort it out in three main pillars: people, process, and equipment. It's no surprise that first applications of industrial IoT were originally focused on safety and health, because the impact on people can be so great in terms of risk on the job, risk of health, and overall awareness of the precious resource that we have in our labor pool, and that they need to be protected, secured, and assisted if we're going to take advantage of the vast amount of resources that we have in that pool. On the process side, there's an extreme amount of waste in processes. If you're able to course correct assets as they were starting to fail in line, then you could decrease the lack of the quality impact and decrease the amount of work in process, which ultimately consumes capital and making that unavailable for the rest of your organization to use and redeploy for research, development, and other campaigns that you want to apply them to. And then, of course, the impact on equipment. You know, equipment which is not running optimally is prematurely wearing. And so you may project a 7-year depreciation cycle on a key piece of equipment, but it'll never last that long because it's being run to the point where it can't be recovered, right? And then for critical equipment, which is a bottleneck to your equipment or a critical resource, that it becomes an asset that can never fail. And so many resources like overtime labor or expedited parts are brought in so that you can eliminate the risk of that equipment not running. And these are all things that erode the efficiency of an organization. Ultimately, if we can perfectly tune the demand on the asset with the demand on the inventory and all of the matching resources like labor and other business domains that are there to support that function, then we've perfectly aligned the right amount of investment for the right asset at the right time. And that's really our ultimate goal. When we have these exposures of risk, risk of quality, risk of production, risk of cost, risk of brand. This is where we tend to overinvest. And so if we break that down into the different business areas where we can realize opportunity, I would classify it in these 4 categories: operating efficiencies, quality improvements, resource optimization, and virtualizing as much as possible the technology on the shop floor, which gives you agility and the ability to change and adjust and take advantage of new opportunities that are coming as a result of these new IoT inventions. I will walk through now a little bit of that, but ultimately, traditional approach for maintenance and investment, where you are doing the same amount of maintenance all the time on an asset, does not achieve the results that you desire. Because what happens is when there's more demand on the production line, you don't have enough maintenance to keep up with the demand, and therefore you have failures. If you're running your lines underneath the levels of maintenance that were required, then you are not using all of the resources that were invested during that maintenance cycle. So ultimately, we want to invest the right amount of maintenance, the right amount of money at the right time, right asset on the right line in order to perfectly align the efforts and results. That's what we're going for with IIoT. And these things are measured. These metrics, asset failure metrics, and all of the metrics that go along with managing asset availability are measured very closely. These are survey respondents from manufacturing sector from Reliability Web Study that was performed a few years ago, and they really haven't changed very much. So mean time between failure, mean time to repair are very common measures that we're using in manufacturing to assess asset failure. And along with that goes the cost, right? Because if there's a failure, you're going to invest cost in order to accomplish what you need to with the asset. Well, that gives you it has an impact on the other measures that you're trying to track and overall KPIs that operations teams are trying to manage. But the thing is, even though operational metrics are focused on things like uptime and asset longevity, executive metrics align with that as well. So these things convert into things like revenue and on-time shipments and responsible use of capital investment and inventory, which ultimately pays back margin and elimination of risk to shareholders. And that's what executives are focused on. Operationally, those convert to things like managing costs and labor and inventory, as well as managing cost of safety or quality and yield. And the thing is, what we've learned is that when you have higher levels of digital density, in other words, if there are more sensors and more electronic monitoring of the equipment that's going on, your unplanned downtime goes down. And so digitalization is delivering value for all of these metrics. But the surprising thing that I think executives have discovered is that as you automate the data collection, as your factory becomes more and more digitally dense, the data is trusted. The data is trusted a great deal more because you've taken away the human factor of making mistakes or not tracking as thoroughly as or as precisely. And so executives trust that data more, and industrial IoT is actually delivering higher and higher value. And this is a really important thing because, you know, when you look at the different ways that assets fail, even though they've been studied decade after decade after decade, so 60s, 70s, 80s, and the 2000s, the results are still the same. Most of the ways that asset fails are related to things that cannot be predicted. There are only 18% of failures are actually related to part degradation or normal wear and tear. Most failures happen because of other outside influences on an asset or because of unpredictable patterns. And so how do you accomplish achieving this level of perfect levels of maintenance if I don't have any visibility on what's happening with that asset? And that's again where automation can help, because if you look at a typical performance to failure curve, the time that a failure starts to occur is actually much earlier than it can be detected by human senses. And so we try to employ all these additional testing, things like vibration or oil analysis or thermography, other physical sciences that can attempt to detect these failures even earlier than humans can possibly detect it. But none of those is as perfect as the monitoring, the electronic monitoring of an asset's performance when it's running in perfect condition. Because when we know that it's running perfectly as it was designed to, then we can start to compare it against how it's running now and how it should run. And then if we have those differences, what are the other variables in the conditions that are causing those things to fail or to start to degrade? Is it in a pipeline? Is it the weight of the product moving through the pipeline in a certain environmental temperature or humidity or other external factor that would cause the motor or impellers to wear prematurely? This is an example of the types of relationships that we're looking for in order to detect these predictive maintenance failures much earlier. Because as it moves further and further towards the time that it completely fails, the cost to repair it and the risk to your business increase incrementally as well. So it's really important for us, for as much as we can, to eliminate risk in the business before it starts to happen. Now, practically speaking, there's no entity in the world that has enough money to maintain every asset in pristine condition to detect these sorts of minute factors of failure. So how are we going to decide where to invest these most precious capital dollars to get the most out of it? Well, here's where reliability-centered maintenance principles come into play. And they're really useful for helping us to understand the role of that asset in my organization so I can start to make intelligent decisions about where to apply industrial IoT mitigation strategies, right? So first, starting out with an understanding of what that item is supposed to do and what its associated performance standards are, tell me what the perfect operating condition is for that particular asset. And then if it does start to fail, how does it fail? What are the ways that it can stop providing the function that it was supposed to be providing? And then what are the events that cause those failures? Outside, failure mode, effects, and criticality analysis. These are terms you may already be familiar with. What happens when each failure occurs? What are these surrounding effects and overall impact on your organization, not only on your own department, but also on the customers that you serve, whether they're internal or external, and on your enterprise overall? What happens? What's the effect? Is this something that could in fact damage your brand to the point where the company is put out of business? And this is not a far-fetched reality. It's happened. And so how does each failure matter? Why does it matter? How much should we invest in this in order to mitigate this problem to a satisfactory level? And if I can't do it, then what's my plan B, right? So John Mowbray, who is the pioneer in reliability-centered maintenance, said that RCM would achieve a reduction of between 20 and 70% in routine maintenance where there's already an existing scheduled maintenance program. And this goes back to that chart that I showed you earlier. Just doing maintenance based on a time-based frequency or based on what your OEM told you needed to be done isn't necessarily the best strategy for your business. If that asset is brought into your enterprise to serve a certain function that's unique to you. And so reliability-centered maintenance principles will help to guide the strategy that you develop appropriate for your enterprise for that particular asset. So it's really important to prioritize how you're going to make these investments. And the risk assessment matrix here that I'm showing may not be unique for some of you on the call, but others, this may be a new concept. And basically, a risk assessment matrix takes into account for each asset how critical that asset is to your business, to safety, environment, to customer experience, or risk of cost. You know, those characteristics or any other characteristics that are unique to your enterprise are the things that you're measuring for in terms of how catastrophic a failure would be for your business, and all the way down to something that doesn't even matter. And if the accident or failure that could happen can happen frequently or even occasionally, that guides you to the strategy that you want to apply for that particular asset set. So in the very catastrophic categories where there's a frequent, probable, or occasional likelihood that failure could happen, that might be a place where you'll invest more in monitoring the condition and health of that asset or the surrounding assets that that rely on its service. So when you're deciding on these projects, you have to think about how does this project contribute to the aim of my organization? So going back to what I said earlier, you'll never have enough money to maintain all the assets in the condition, in pristine condition. And so backing off of that, what is that asset intended to do for my organization? In order to know that answer, you really have to have an understanding of your own enterprise. And for this, I'll use my pizza analogy. For those of you who've heard me speak before, if you are the pizza maker who promises pizza delivered to your door in 10 minutes, your focus is going to be on the assets that help you meet that commitment to your customers. So you'll be investing in fleets, you'll be investing in how do I keep that food hot in transit, how do I cook it quickly, right? Because your value prop to your customer is speed. If you're the pizza manufacturer who is making the best pizza ever, like people should be willing to wait an hour for this pizza because it's so good. Your focus is going to be on the quality of your ingredients, the kinds of ovens that you're using, the skills of the people who are making those ingredients. Maybe you want to trace those ingredients back through the supply chain to assure that, in fact, they have traveled in a gluten-free environment, for example. That's going to change your perspective. So when you're making decisions about where to apply your own IoT investments and capital, think about how that project is going to contribute to your overall aim of your organization. And then, how quickly do we want to see results? Sometimes you experiment with technology projects, not necessarily with the intent to take them to scale or full deployment through your enterprise. You may decide that you have a different learning objective for that particular project. There's no answer that's completely right. It has to be right for you. And so you choose the projects and you decide where to invest based on conscious decisions and answers to these kinds of questions. So going from the bottom up, run to failure is an appropriate maintenance strategy for some assets, like the radio in your car. If it fails, it's a little inconvenient, but nothing's really going to happen other than you're a little bored on your ride. But if moving up from that scale, you may apply more of a preventive routine where cyclically you go out to perform a function You know, in the analogy that we use for your car, that would be like changing your oil every 5,000 miles or whatever your interval is. Many of the new cars now come with sensors, so they can tell you, oh, well, your oil has too much particulate in it. It's time for you to take it in and have it changed. That's a condition-based maintenance strategy. You may also, for those more critical functions that are necessary for the asset to function itself, you might move into more of a prescriptive style of maintenance, and that might be more testing on a continual basis or monitoring the supply of the resources that can impact that asset and cause them to fail. An example of this might be monitoring shielding gas that's being fed to a welding line to assure that you don't have porosity developing in the line as it's being laid. That would be an example of predictive technology where you're monitoring the external resources that are being fed to that asset so it can perform its function as it should. Or for very, very critical and high dollar amounts, high capital processes, you may want to apply more of a prescriptive model. So, for example, let's say you're a steel manufacturer and you are making batches of steel in accordance to customer specifications. Well, sometimes during that process, in the melting, mixing, and with the variables found in raw materials, you may find that batch is not necessarily going to meet the customer contract specifications that it was originally targeted for. You may then have the opportunity to quickly, on an automated basis, evaluate the characteristics that are coming out in that batch and see if there are other customer contracts that may be able to consume it, or if it's something that you could auction out on the market. So this is an example of prescriptive analytics, and really in this world of technology and capabilities, as you move up in the stack, you require more IoT and analytics in order to be able to accomplish those things and to be able to really conquer the challenge of managing those random failures, the random failures that are eroding your profitability, quality, and ability to meet mission for your organization. So if you look at this, and we've been talking about this from the manufacturer inside the four-wall perspective, but if you think about this from the OEM perspective, we've seen a lot of market disruption in this area, because as assets become more intelligent and connected, now they can feed how healthy they are to the OEMs and the engineering teams behind the scenes who are responsible for perhaps aftermarket services. Cummins has done a great job, and a lot of heavy manufacturers have done a great job of transitioning their traditional customer relationship of singular product transactions to more extended, involved, service-based contracts. In fact, Rolls-Royce was really a pioneer in this industry early in the 2000s when they stopped selling their jet engines and started selling only the hot air that comes out the back of the engine. So their guarantee to the airlines was, you're always going to have a performing engine on the wings where you need it. Well, that enabled them to transition their revenue model to more of a consistent services-based model, healthy for the organization and disruptive, because what asset owner wouldn't love to push the maintenance off back onto the OEM and only buy the services that asset is intended to deliver? We're seeing that a lot. We're seeing that a lot in different kinds of industries. In fact, I was at a chemical company not too long ago who told me that they're transitioning the sales of their chemicals to deliver the white on the paper. So that is market disruption. and that's what IoT can certainly do. If you look at from the efficiency, now this goes back to the inside the four walls perspective of OEMs. One reason this is so compelling for them is not only can they delight customers, but they can also save a lot of money on the inside of their organization and how they manage the process of receiving a call for repair and actually accomplishing that repair. Oftentimes, these OEM service contracts are tied to SLAs, so the customer pays a flat fee every year for that service, regardless of whether it's an emergency or not. So any emergency or asset failures that are impacting that service level agreement for customers requires the OEM to invest a lot of money in overtime and emergencies and time, unplanned, which result in unplanned downtime for customers. So by adding additional insight and access to the health of the asset as it starts to fail, you can actually start to prepare for that repair much in advance and much more electronic activity-based as opposed to hands-on work in order to accomplish the repair for the customer. And wouldn't your customer be delighted to receive a phone call saying, we know that your fan is going to fail on Thursday approximately between 3 and 5 p.m. So we want to schedule a repair in on Friday morning at 7 so you don't have any downtime on your line. And wouldn't that be very disruptive to the market? And that's really what we're seeing. So ultimately here, I want to summarize by talking about the fact that if we want to achieve ultimate asset performance management, it's really a combination of not only technology, but also the processes that you have to put in place. Processes in terms of understanding what your reliability strategy is for each of the assets that you have running in your facility, but also understanding what your strategy for managing that asset will be according to its criticality, right? And that's levering all of the tool sets that we have available to us from the reliability-centered maintenance and from failure modes and effects analysis tools to give us the opportunity to make decisions about how those asset failures will be treated. Because again, not every asset failure is created equal. They have different effects on your organization. So you build that into a rule. If this criticality and if this happens, then we do that. And those solutions, those rules get integrated into your solutions via interfaces and libraries using common integration standards, APIs and OPC UA and MQTT and all the other standards of communication so that the machines can interface with the business systems and send indicators to the places where they need in order to take action. That brings up another conversation. Where do I make that decision? Sometimes if I'm monitoring the health of a condition, like is the label in the place where it should be? Is the bottle turned in the right direction? Is there a bolt in that hole? Those are all quality issues that could be measured and monitored right at the edge of data collection. Some data is not worth collecting. It's useless at 3 seconds after it's been collected. So that analysis and computation of its value is determined as part of your reliability strategy. So you make decisions on what to do with that data, whether it should be sifted at the edge and responded to right there, or if there's value in examining the trends and the shifts that I'm seeing from that asset moving off of perfect performance. There's value in understanding that drift. The drift that might be caused by other outside failures, other outside variables that are impacting, as in the shielding gas example that I gave you, there is context to every equipment, and that's really the holy grail in this world of artificial intelligence and predictive analysis. Maintenance specialists say they have a gut feel about, oh, it didn't sound right, it didn't smell right. I never could understand why some days it would work and some days it wouldn't. These are key clues. And I think also really important to recognize as part of the transition as you're bringing your culture forward in this world of technology, because we have to validate that the input from these specialists has meaning. They need to be partners as we're building these predictive models and weighing the impacts of these different variables in the machine learning and deep learning models that are built in algorithms that live at the edge or live at the enterprise level, depending upon where you make decisions and where to maintain that data. All of those things can feed into a condition monitoring model that serves the facility, the plant, and the overall enterprise. There are very sophisticated organizations out there that have huge control rooms that can see their fleet of assets globally, and they can predict when there's going to be failures in different areas and move product and move customer order production to places where they're healthy. Now, this is a lofty goal. It takes decades to get there, but it is where we are eventually going. Sometimes your data collection will be involved in, or will be collected via inspection or operator rounds. There needs to be the opportunity for people to input their observations and human interpretation of what's going on, because we haven't yet gotten to the point where the capabilities of compute and artificial intelligence have gotten to the point where they can do a better job of that in analysis interpretation without the benefit of having that input, that actual perfect input coming from the sensors from the equipment. So with the combination of autonomous measures, the assist of artificial intelligence and looking for patterns and suggesting inferred recommendations for repair, the human analysis can also add insight and important dimension to that. So once we build enough of where we can train these models to the point where they can understand fully these human decisions, then we can move into fully autonomous operations. But it will take a long time for that to happen. From data collection, the results and events and alarms obviously need to trigger follow-up activity. So follow-up in terms of managing the asset health, doing the repair, but stepping back and doing some analysis in terms of, really what is the problem that's causing this failure to begin with? What are the bad actors in my organization that I can focus on in order to eliminate one of my top issues, top 20. And so from this insight and improvement, they can all be driven back to reliability strategy for the overall organization to create a holistic asset performance management strategy based on a combination of electronic input coming from sensors and monitored devices, as well as tools like edge processing, artificial intelligence, and the science of manufacturing methodologies that holistically make for a healthy organization. So that's what we're dedicated to doing here at the CSI. We are committed to creating the workforce of the future who can help enterprises achieve these goals of future perfect operation, of right amount of investment, right amount of cost and right amount of the right asset. So this requires really a well-balanced menu of topics and information that will help you in order to create this workforce of the future. So we'll be focused on these lecture series, which you've seen, which will feature topics related to not only technology, but also those other topics of process, people, and the softer skills necessary, like lean manufacturing and Six Sigma and 5 Whys sort of capabilities, the science of reliability married with the deep technology resources in order to help produce the people knowledge that's necessary in order for you to accomplish your goals. So we'll start out with these lecture series. We're really honored to have a large group of specialists and deep industry specialists working with us on these workshops, in addition to the deep bench of faculty and research that we have here at the university. So my intent is to blend the best of academia with the best of industry and bring them to you as our customers to help you achieve your goals with IoT. So we'll start out with the lecture series here. Some of these lectures will turn into workshops that will deliver either online or in person here at the CSI. Following these, we'll also form digital roundtables. And so these are intended to be very small groups of cohorts who are each working on similar use cases in their organizations. And we'll pair these roundtables with Sherpas or people who've traveled that journey before, so that each member of the group can crowdsource and take advantage of that experience within their group. We can also provide support for collaborative research. In the upper right here, you see a diagram of a fully functional vial filling machine, which we'll have here at the CSI alongside of our digital twin simulation lab. The whole idea is that the students and adult learners can come and test out their programs in the simulation lab, pull out the cartridge, walk over and plug that into the line and see what they had just created manifest in a physical performance on the line itself. That line features unique traceability for product as it's traveling through the line, because each one can be serialized and barcoded. There's 4 different kinds of robots on the line moving vials around, testing that the vials have been filled with the correct colored fluid based on the recipe that was sent down from SAP in our business school, right? So this is a fully functional line that will be mostly focused on discrete sort of operations. In our second lab, we'll have more of a process line, piping, valves, pumps, motors, things like that. The whole idea is to be able to provide a test bed for education and collaborative research, but also an important part of these test beds are that all of the data that's generated off of them will be sent up to the cloud so that it'll be available for researchers anywhere. Now, that's not normally a best practice. Like I said, some data needs to be sifted right at the point of completion, but we made a conscious effort to not do that, to make the data available for all the researchers ubiquitously so that we can foster innovative growth. And in fact, I do want to point out that one of the lectures that we'll be featuring in May is focused on research in this area as well. Through these lecture series and workshops, we'll be developing a body of knowledge. As Charles had mentioned, we're going to be recording this call and making it available after the session from our website, so you can download it or listen to it, share it with others in your organization that should hear. So you should expect access to all of those lectures right at our website. We can help matchmake for benchmarking and assessment services as well. So we really want to become your partner in creating the workforce of the future, looking for or being a research partner, and providing a reliable source of curation for important knowledge and data that you need to have as you're traveling your own IoT journey. So I'll pause there now, and let me just finish up with, as I mentioned, workshops and courses. We also have a mission to develop coursework and certificate programs that will be focused on developing the talent and the skills that industry needs. And it will fall in 4 different pillars, spanning from level 0 factory automation capabilities, layering on best practices like what I just talked about, including digitalization strategies and the application of OT and IoT. And keep in mind, we will have traveled that journey here in the CSI as well. So the people involved in that become our teachers and become our Sherpas, or you, our customers. And our overall goal is to drive deep explorative research in artificial intelligence and other disruptive technologies, because together we want to recreate, reinvent, reestablish the Midwest, Milwaukee, and the University of Wisconsin here as in the renaissance of manufacturing for Wisconsin. Obviously within the constraints of our current quarantine. So I'll finish here with just a review of our lecture series. I'm calling on a number of thought leaders from around the world, and I can tell you actually that I have another 5 or 6 behind this that will be announced shortly. These 1-hour teleconferences will be recorded and stored on our website. We'll develop our body of knowledge, and which will be available to you from the website for replay. So with that, I'll pause for questions. Charles, do we have any?
Yes, we do. So if you could mute yourself for 1 quick second, Mary, and I will share my screen here. All right, so we have a few questions that I've picked out for you, Mary. The first, analytics is the biggest boon in the last 10 years because we have all this information, but it's only good if it allows me to generate action. There's so much data being generated, but we still can't use it without someone looking directly at it. How do I help my team develop meaning from the data and understand the value of it?
That's a really great question, Charles. Thank you for whoever asked it. You know, technology in itself is not going to fix the problem. Technology is only effective when it's applied to real life applications based on the real needs of the people that you're trying to serve. So the most effective way to get the culture, to move the culture to adopt this kind of technology is to assure that it is meaningful for them. So when we go out to talk about projects or get involved with project teams, we always look for domain experts. This would be the maintenance guy who's been working on that equipment for the last 20 years and knows it intimately. You want him on your team. Or if you're developing tools for a younger labor pool, millennials, and they're used to video games, the gamification of information, the streaming data, dashboards. You might want to bring somebody like that, a gamer, onto your development team, right? So it's really important to look at the customer pool that you're trying to appeal to and make sure that you have representatives from that pool on the project team so you can make sure that the solution is meaningful for them and that it doesn't miss what it's trying to accomplish. But most importantly, making them part of the solution gives them ownership of making sure it's deployed. Here's a place where you should make use of your naysayers, the negative people who say nothing, it can't work here. Bring them on your team and find out why they think it can't work. Because if you can win them over, you'll win the rest of the organization too.
Okay. So Next question. Automation displaces human work activities and changes what people do. Can you share some strategies to manage this transition from other industry leaders?
I mentioned one technique about bringing the naysayers on, but also this is classic change management capability, right? People fear change. They fear how it's going to impact their work. So change management principles are super important in this part of the project. And so actually the best answer for that question will come in another 2 lectures or so. One of the lectures that is in the hopper that hasn't yet been announced is dedicated to change management. So we'll have an esteemed professor and highly respected professor talking about, Alan Klotchke is his name, talking about change management methodologies as well as input from an industry perspective. So John Fortin from Jacobs Engineering will be joining Alan to talk about discussions and actual examples from industry via a study that John has been performing. So tune in a few weeks for more detail on the answer to that question, Charles.
Excellent. Another question, my leadership is asking me to develop a roadmap for our organization to develop a digitalization strategy. What are some of the criteria to consider as we're deciding where to begin?
Well, going back to what we started with, what is the aim of the organization? Are you going to be the fast pizza manufacturer, or are you going to be the quality pizza manufacturer? The answer to that question leads you to the assets and the places where you have risk in your organization, and then the level of risk that you're experiencing there. If it's great, that might be a place where you decide to invest the most in terms of automation and monitoring that capability. If it's market disruption you're after, and believe me, this is the time when we're going to see just a tremendous amount of disruption. New products that were never invented or thought of before will blindside traditional players, and you can see this all over. Look at streaming video and how it disrupted the movie rental business, right? We're kind of in that same phase right now. So I would encourage you, as part of the aim of your organization, to look at ways to lever strengths that you have already internally to use it to disrupt other adjacent markets that you're in. This is a huge time of opportunity. Let's grab it.
All right. Well, that's all the time we have for today. Thank you, Mary, and all our listeners for your great questions and active participation. We'll be posting a recording from today's session on the CSI website events page. You'll have access to that very soon. I'll also invite you to tune in next week when we'll hear from Matt Friedel, an angel investor with Silicon Pastures Angel Investment Network, a senior lecturer here at UWM and an adjunct faculty at Marquette University, and a co-founder of the Disruptive Technologies Laboratory here at UW-Milwaukee. Matt's lecture will focus on illustrating how businesses are using AI and machine learning to boost performance, drive efficiency, analyze market preferences, and enhance manufacturing. Please register for this event at uwm.edu/csi/events, or you can go to our Connected Systems Institute LinkedIn page and view our events there as well for registration. My name is Charles Mosley. If you have any questions about today's event, you can reach me at cmosley@uwm.edu. As your host, I'm signing off for today. Thank you, everyone, for joining us, and we'll see you at next week's Technical Tuesday lecture series event. Sorry, got my words mixed up there. Have a great day, everyone.
Thank you.